Alright, so today is a rare Monday programming lecture. We're going to do Pong in Python. Finally, we have the two pieces. We're gonna hook them together now. Let me fix these pens. There we go. So we've got the paddle moving up and down. We know that. We also have the ball just bouncing around all over the place, which is mostly all we need, right? I just got to hook the two up together, and then we will have Pong in Python, and that will be very exciting. All right. I do want to foreshadow and say that this is going to be your last programming assignment. So I'm just going to ask you for your final programming assignment as like a winter holiday present to just recreate everything that I do today in class. So I will, of course, not be giving you the files. You'll have to follow along with the video if you want to go back and do it. But this will be your last programming assignment. Do what I do today in Python. All right. So yeah, I don't have a ton of slides. It's just going to be mostly coding, and it shouldn't be too long because we got most of the way there. All right, we just got to combine our two programs. So yeah, without further ado, let's make Pong. So what do we need? What do we need here? We want to make sure, like we checked this before, we want to make sure that our paddle doesn't go out of bounds when it hits the top and bottom walls. And so we use like if statements and stuff like that. Let me pull up the two pieces of code that we are going to combine today. Dun, dun, dun. I guess I want to talk about the paddle first. So we got paddle.py and 2dbounce.py. Those bad boys working together. I'll put the REPL over here. Don't really need it. We also made the paddle program here. And this was most of the way there. So we made this program. And let me just remind us what was happening. Drew a bounding rectangle, made the turtle a square and stretched him in a weird way to turn him into the paddle. And then always hard code his starting position, middle of the screen, -170 on the X. And then we made two functions called go up and go down. And those are going to be called every time we press keys. We did this turtle.onKeyPress thing. And that was nicely a way to like hook into a key, the up key and the down key. Whenever those get pressed by the user, it's just the turtle will make sure to call these functions for us, the go up and go down functions that took care in moving our paddle a little bit up or a little bit down, and also making sure to not go past the edges. So like press up, or you can hold in up. We're bounded at the top and also bounded at the bottom, which is beautiful. And yeah, let's remember how we got there. So we used an if statement, a very carefully crafted one to check and see was that in the right spot. We don't want it to go too far. So it's always relative to the center. We're always like checking where that turtle is relative to his center, and it's also going to deal with the width as well. We had to worry about that. Apparently his width is 120 units right now. And so when is he just grazing the tippy top? This is the y equals 200 line, right? For a 400 by 400 box centered at 0, 0. And so we want the paddle to not go any further than this, and his y coordinate is going to be relative to his center. So that's going to be our y equals 140. And so that was the special number we don't want to go past as we're moving up. And there it is. There's us hard coding it. If we ever try to go past it, make sure we rein the turtle back in. Don't let it go ever any bigger than that. Okay, so that's perfect. And then actually move the turtle. And then same for the bottom wall. The bottom wall, we're moving him down by 10. And then likewise for positive 140, we had something at the bottom for negative 140. Don't go any less than that. That's outside of our range. Rein the turtle back in. And then actually go to that new spot that you've calculated. Okay? So that is pretty much that program. And it's working, which is beautiful. And now I want to combine the two things. So the turtle is the paddle right now, right? Here's that program with the turtle being the paddle, turtle.goto all over the place. But we do have a problem now, don't we? Because look at our 2D bounce program. It's randomly bouncing around and doing cool stuff. Whee! What's the ball? The turtle is also the ball at the same time. So there's a bit of an issue there. We're going to have to reconcile those problems. Like we've got a turtle that needs to be the ball as well as a turtle that needs to be the paddle. can you have two turtles? That's now a new question that we don't know the answer to yet. Luckily, the answer is going to be yes. All right, so that's going to be the game that we have to play here. So the turtle needs to be both the paddle and the ball. Luckily, we can have multiple turtles. And so now I need to talk about what the syntax is doing. When you import, it's a little weird. When you import the turtle library, there's always one default turtle that you get. You get a default turtle, and that's the one that's moved when you say turtle.right, turtle.forward, all that nice stuff. Turtle.goto, that's moving the default turtle. You can make your own extra turtles. There's always one. You always at least get one. You can make your extra turtles by saying this. You can make variables with new turtles inside of them. It'd be like paddle equals, and then here's a function call in the turtle library. It's called capital turtle that makes a brand new turtle. The second I run this line, I'll make a second turtle on the screen, which is pretty cool. And then I can use it just like, once I say this, just like this paddle equals turtle.capital turtle, I can use that paddle variable like the normal default turtle all over the place. Instead of saying like turtle.goto, now I can say paddle.goto, paddle.forward, all that fun stuff. So we're going to do that. Paddle equals this. We're going to make a new turtle called the paddle, and then we'll also make a new turtle called the ball. And I think that will be that. So let's get all that hooked up together. I don't know if I want to start with, which code do I want to start with? Do I want to do the paddle code or do I want to do the ball code and copy one into the other? Let's see. I guess it doesn't really matter. Let's start with maybe the paddle code because I've got that open already. I want to make a new file in a place that you don't get to see. I will not be giving this to us today. So I guess I'll have to put it in like my CSCI1 folder. We'll call it pong.py just for me. Here it is. And this is just the paddle program right now. So I'd like to do the following. Let's do all this fun stuff. Let's make a new turtle for just the paddle, and then eventually we'll copy in the ball program too. I think that's a good strategy. So here's the Pong program. It's just the paddle program right now. So if I run it, it's all the old paddle stuff. Okay, so there's all that. Let's do also this bounding rectangle. The default turtle is drawing that rectangle as well right now. I think that's fine. That's not an issue because we're eventually going to we're not going to need that default turtle, so we can still draw the rectangle. That's still fine. So we'll use the bounding square drawing code from before. We'll keep all of this, and then now this new stuff. Make the turtle the paddle. That needs to change. All right. So let me section off this program because this is now all the code down here is all about paddle stuff, isn't it? Paddle stuff, we'll call it. Let me try and make this pretty. Exactly the same number of number signs over here. Beautiful. All right, so this is all paddle stuff down here. And so instead of saying turtle dot everywhere, I'm going to make a brand new turtle right now for the paddle. So not make the turtle the paddle, make a turtle for the paddle, a new one. That's going to be our game now. So I'm going to do exactly what I said in the slides here. I'll say paddle equals turtle.capital turtle. All right. So paddle equals turtle.capital turtle. And it's just like a function call. It creates a brand new turtle. And now, once we have that, now we're going to say, paddle dot blank, paddle.goto, paddle.shape, all that stuff everywhere. And if this is all the paddle code, everywhere I said turtle.something, it needs to become paddle.something. So I'm working with the paddle now. Paddle.shape, paddle.fill color, paddle.turtle size. These variables are cool. Those are already just normal things, paddle x, paddle y. Paddle up, paddle.goto, all that. Paddle.goto, those are just variables, not turtle.goto, paddle.goto, paddle.goto. So I think those are good. And then we're also just going to use the default turtle is still sticking around on the screen. He can, in addition to drawing the rectangle, he can just keep on listening for the key presses. So I'll just keep the default turtle listening for the key presses. I think that's fine. Let's see here. Do I want to make a comment for that? I think that's fine. So I think there's all my paddle stuff. And then also the listening will happen from the default turtle still, calling the functions that mess with the paddle turtle. Okay, so I think that should do it. Does that code make enough sense for now? All right, let's try running it and see what happens. So I've really just changed a variable name. I didn't really have to because I haven't added the ball turtle yet. Let's just make sure everything's still working. It's a paddle dot everywhere now. We got a few problems here. We got a sideways paddle, interesting. Still can move up and down. And then notice that the original turtle, the default turtle, is stuck up here in the top left of that rectangle, which is where he stopped. Right? He was drawn, at the very start we told him to draw the rectangle, and then because we didn't make him immediately the paddle, he's just stuck there. So we've got some new things we need to mess with now. So you can hide the default turtle. I think it's just like turtle.hide or something. Let's go to the documentation to confirm that. Python turtle. Just want to hide that turtle. So you can ask the turtle to hide himself. So it's .hide turtle or .ht for short. And so that will hide the turtle. If we want to do that, we can hide it right here. Turtle.hide turtle. Boop. And so that hides the default turtle. That's fine. And so now when I run this, you'll see that there's the turtle. His shape is there. He's drawn the rectangle, and then he hides himself. And then the paddle's still sideways. So the reason it's sideways is a fun one. It's because by default, every turtle who begins their life is facing east or to the right. That default turtle that we used to draw the rectangle, what was his last direction? It was up. And so we stretched him according to those rules based on his current direction. But this default turtle is not facing up by default. So we can either stretch him in a different axis, stretch him in a different way, just like stretch him 6 1.5, that would work. Or we can just tell him to turn himself up. That works too. That's not a problem. So I think that would probably be the easiest way to fix this. We'll just be like, hey, default, or not default turtle, but paddle turtle, paddle dot, just like you're facing right, go and turn, if he's facing right, what direction do we want? You're facing that way, turn left by 90 degrees, and then you'll face upwards, and you'll be like the old turtle. And you'll be stretched in the right way at that point. So paddle.left, we'll say, by 90. And so that makes that turtle face upwards. Now facing upwards, and then everything else should be as it was, because now it's in the same orientation as the original turtle. Got that new turtle beginning its life, being stretched in the right way, and I think we're back to as we were. So I think that was everything we needed for the paddle. Does that make sense? All right, so that's nice. That's working now. Just needed to preserve all the old stuff, and seems like we're in a good spot. And so now we're ready to copy in the ball stuff. All right, so let's copy in the ball stuff, and I guess I'll just make a new section for that. We've got paddle stuff. That can all be dealt with up there, and then we'll do ball stuff down here. So there that goes. And then I need to copy in that entire program, or just the relevant new things, because we still had like the rectangle drawing code, all that fun stuff. So let's copy in all of that from the 2D bounce program. Let's see. The rectangle stuff we don't care about. It's just from here down. Make the turtle the square downwards. And we're going to have to change a lot of variable names, because that's default turtle stuff again. I guess technically you don't have to make a new turtle for the ball because you made a new turtle for the paddle. You could have used the default turtle for the ball. Now that would work. But let's do it right. Let's make a brand new turtle for the ball and get some practice with that. Let's see here. So make the turtle the square. No, make a brand new turtle for the square. Not the square, but the ball. Okay. So let's see. Just like I was doing paddle equals turtle.turtle, I'm going to do ball equals turtle.turtle right there. So we'll call it ball. And now, just like the other one, now we say ball.blank, ball.forward, ball.shape to move this turtle. So that's what we need there. Let's see. So yeah, instead of default turtle messing with stuff, we're going to say, no, your shape is for the ball. Ball.shape, ball.fill color, set it to purple. Ball.turtle size, stretch him. And then we were also using these variables called turtle width, which is, I guess, now incorrect. We want it to be called maybe ball width. So let's change those variable names as well. So turtle x becomes ball x. Turtle y becomes ball y. It's not turtle x offset, it's ball x offset. Ball y offset. Mess with them there. And so yeah, yell at me if you watch me or forget one. But I'm going to change turtle to ball all over the place, including in just the longer variable names. Ball.up, ball.go to your initial spot, which is in ball x, ball y. And then all these global variables as well. It's not turtle x anymore, it's ball x, ball y, ball x offset. All those bad boys need to change. It's going to take a while. Are we calling it turtle width or ball width? Yeah, I called it ball width, like I should have. Ball y, ball width over 2. So this will take a second, but it's useful. I think there's also like a find and replace feature in idle, but I guess it's more educational to just do it manually. So messing with all these, we got new names. Brand new turtle, all new names. But we're almost there. Ball x, ball width. Ball x offset. So close. And if I forget one, Python will eventually yell at me because it's like that variable does not exist. So that's useful. But we are so close now. Now it's draw frame's turn. Global ball x, global ball y. Let's see what else. Ball x offset, ball y offset. Almost there, almost there. So mess with the ball's x position, have it be affected by the x direction. The ball's y position should be affected by the y direction. We need to bounce, so that's a function that we already worked on. Changed all the variables over, and then now ball x and ball y has new numbers inside of it. We need to go there, actually move the turtle on the screen. So I think that was all of them. Let's see if that works. So I'm messing with ball dot everything all day long now for the ball stuff. Let's see if that's happy enough. If we're lucky, it will be all we need. It looks like we're almost there. It looks like I forgot something though. Let's see. Am I in the right place in my notes? Ball width. More or less. So it looks like I forgot one somewhere on line 91. How dare I? 91. Where's that? And if you don't want to count lines, down at the bottom it's saying, it's very small, but you can see it's LN 94. That means line 94, column 38. So like the columns are the X and Y. There's line 91, and it looks like, okay, way over here, I forgot these. Ball X offset, ball Y offset squared. There we go. Try it again. That's nice that Python yells at me if I forget. But it looks like it's gonna work now. Very nice. Awesome. So, let's see. The ball is kind of moving a little slow. So, if we want this to be like a normal game, the paddle is like overwriting the ball. It's not hooked together yet. This is a very slow, easy game to win. Let's change the speed of the ball, and that had to do with the hypotenuse of the direction triangle. So we made it 1 before by dividing by all that. Let's make it 2 by multiplying the x offset and the y offset after we normalize them by 2. So now that will make the length of the direction hypotenuse 2, and that will make the ball move faster. Let's try that, and that will make for a more interesting Pong game eventually, I think. That's a more appropriate speed. And wow, that almost hit the corner there. So I think that's a valid game. So right now, sadly, the ball and the paddle, they're not hooked up together, but they work. And for a weird quirk of the library, if you hold in the keys, it makes the ball go slower. Which is funny. It's like it's got to take time to process your key presses. Which is a little funny. That's like a cheat maybe. But I do not have the tools to fix that for us. It's too complicated. But that's good enough. Yeah, so we got 2 turtles, each doing their own things. Or I guess technically we still have that secret default turtle who's hidden in the top left corner there. We got the paddle stuff with a new paddle turtle, and we have the ball stuff with a new ball turtle, and maybe we can change the color of the ball to like blue or something, so that we have some interesting stuff going on there. So like a purple paddle, a blue ball. Cool. Slightly different now, and that was just the fill color. The fill color, you change that changes the color of that entire turtle, which is perfect. All right, so we're almost there, I guess. We would like to clean up a few things. We still have to hook up. The big thing is hook up the paddle to the ball, and then make the game losable. So we have to stop the game if the paddle actually doesn't hit the ball. Like the ball hits right now on the left side there. We want to like stop the game. So those are a few things we need to work with. Let's see. I have an order to this. So one thing that I haven't talked about is due to the randomness of the way that we're making the ball appear, it's possible that you might immediately lose the game because maybe the ball, like it begins its life way up here in this top corner and it's like going to the left as well. And so it's like you have immediately lost the game as you started it. So just due to the randomness, that is possible. You might choose a left direction and make the ball way up here. Sometimes you will, sometimes you won't though. But that is a possibility. Let's see if I can get it. I'll try one more time. Yeah, okay. So at least you see that it's possible. We want to make it so that that doesn't happen. So like right there, for example. At least it would have hit the paddle. But in theory, you see the problem. And so one easy way to solve that problem is to just make sure that the ball, when it begins its life, we're picking a random spot and a random direction for it. Let's just make sure that its random spot is somewhere on the right half of the screen. Do you see that would prevent things? Even if it was going to go to the left, you have time at that point because it's got to move half of the screen at least to get over there. So let's start the ball somewhere over here. So it's still a random y coordinate. It could be way up here, it could be way down here, but the x coordinate, let's make sure it can never be negative because these are like negative x coordinates. Let's make sure that the coordinates for the x of the ball initial position is always positive. That will make it so that it always starts on the right-hand side of the screen. So I think that will fix that. Good enough at least. Let's see. Where do I want to do that? Where do I pick the random location of the ball? Ball x, ball y. It's right here. So here I am, ball x, ball y. And so the random x being able to be small, let's start on the left side. We don't want that. So let's say that pick a random x coordinate between 0 and 150. That'll make sure it's always on the right. Start on the right half of the screen, and that'll be perfect. Cool. And so now whenever I run it, even though I might choose a random direction still to the left, you're going to have time to get over there. Right? So it'll always start, look at the ball, it's always going to start on the left-hand side. So it did that, and it was even moving left. So there's time, though. There's time to move the paddle and still win the game, or at least stay in the game. So yeah, it's always, every time I run it now, it's going to pick an x coordinate that's non-negative between 0 and 150, so it'll always appear on the right-hand side. The y is still random, so it could be at the top or the bottom of the right side. But yeah, that's better. All right, we won't have our players of this game angry at us now. Let's see what else. I guess now the last two pieces of the puzzle is we need to be able to bounce off the paddle, which is going to take some thought. And then also we need to be able to lose the game. So like if we forget or we miss, can I miss? There it goes. So if we miss and the ball ends up hitting the left wall, that's the special wall, right? You're not supposed to ever let hit. So like that means you missed it with the paddle if it ever hits the left wall. And so we should stop the game if it ever does that. I think maybe we'll do it in that order because I think it's easier to notice if we hit the left wall. I'll show you how to do that. So if the ball ever hits the left wall, it is game over essentially. And so an easy way to keep track of if the game is over or not is to use a variable. So here at the very start of the game, what we'll do is we'll make a variable called isGameOver. And at the start of the game, of course, that's not true. So false, right? isGameOver should be false at the start of the game. But eventually, if you ever lose the game, it will become true, okay? So let's make it true when it needs to become true. So where does it need to become true? It's whenever we hit the left wall. So where's the piece of the code that's noticing if we hit the left wall? It's like down here in the bouncing part, right? There's the bottom wall code, top wall code. Here's the left wall code. Essentially, what we want, we can do all of these things, keep what was there. It doesn't really matter. Honestly, you don't have to change anything anymore. But the second you hit the left wall, in addition to doing whatever else you were doing, it's never going to move again, so you don't really have to change the offset. You can get rid of that if you want to. But it should be game over now. Game over, stop the game. And so what we'll do is we'll use our variable to keep track of is the game going on or not. So is game over is false right now as you're starting the game, but eventually if it ever hits the left wall, we'll change is game over to true. And because this is a global variable that we're modifying inside of a function, we have to mark it like that up here with global. Global is game over. And so now it'll become true, and we want to stop the game when this variable ever becomes true. And so the secret is going to be the loop that was dealing with moving the ball. Right down here, it's just like forever. Until the end of time, draw a new frame because the ball wants to move forever. But we want to stop the ball if the game is over. So instead of while true, we'll say, while the game isn't over, move the ball. Does that make sense? Eventually, if the game ever becomes over, it'll stop it. So while the game is not over is a Boolean condition, right? So while it's not true, so here's one way to do it. While is game over is false. That's one way to check it, okay? While is game over is false. As long as that is true, right? That's a true check. Keep drawing a new frame. But there's a way that people tend to prefer instead of writing it this way. Notice how it's just like you want to make this condition true. As long as this condition is true, it will run the body of the while loop. So instead of saying while is game over equals false, that's a lot of typing. People tend to do it this way instead. They just say while not is game over, because this is a condition that will like flip the is game over variable. So if it's false, the result of the not on it will make it true. And that will continue to run the body. And then it kind of looks more like English. So like while the game is not over, essentially. And so people tend to write it like that, but you could have written it the other way as well. And so now, if this loop is going to stop, the second is game over is true, right? Because not true is false. While loops go only as long as their condition is true. And so the second is game over becomes false. Becomes true right here. We're going to stop that program. So let's try running it. And let's lose the game. All right, where's it going to hit? There, I'm losing the game. Bam, perfect. And so the ball stopped because this game over started out, like its life started out as false. The game's not over yet. But we notice, like if we ever hit the left wall, that was our fault, right? The paddle should have hit it by then. And we'll stop the game. This game over becomes true. And that's going to affect this while loop, which kept drawing the ball in new places and moving the ball. So we don't have any more frames. We are done now. So that stops the entire program. Okay? Questions about that? Does that make enough sense? Cool. So yeah, that's the beauty of it all. So I guess the last piece of the puzzle is to hook up the paddle. Hook up that paddle because right now, even though the paddle might hit the ball, we're not noticing it. And it will just immediately stop the game. So we have to like make the paddle visible. It's invisible kind of right now to the ball. Let's see here. That's the last piece of the puzzle, and that's going to take a brand new slide. All right. So what we're going to do is let's make it easy on ourselves, just like we were doing a function for like all right every new frame. What do we need to do? Mess with the ball, bounce off of a wall if we ever hit a wall. And then now we just need to bounce off the paddle too. So like, let's make a function that we can just like do this with. And just be like, all right, if you ever hit a ball, bounce off. And then also if you ever hit a paddle, bounce off. It's like, hand off the problem to ourselves. That would be nice and make it cleaner, I think. So if we hit the paddle, also bounce off. So that will be the order. Just every frame, all right, mess with the ball's position, bounce off a wall if we ever hit one. And then also if we hit the paddle, like, we might hit the paddle too, so bounce off that as well. So now, I guess the last piece of the puzzle is just like implement this bounce if hit paddle function, and we have pump. And that will keep track of like, did it work or not? So I'll say def bounce if hit paddle, make that function now. I just need to like do the bouncing, do the check if the ball hit the paddle, and then also bounce off. That's where all that code needs to go now. All right. So let's see. Got to bounce off the right side of the paddle. Like notice it hit the right side of the paddle because that's what it means to bounce. It's the right side of the paddle, nowhere else. So, all right. now we need some conditions, because we're going to do something very similar, right, to the bounce of hit wall functions. Like, all right, if the ball is x and y are in this particular arrangement, then we need to do our bouncing and run that code. So it's going to be some if statements, or maybe just one if statement, honestly. But it's going to look like this, bounce of hit wall. We're going to have some conditions, and like, all right, if it's true, that means we hit the paddle instead of the wall this time. So it's going to look a lot like that. And so now the question is, what are those conditions? It's going to be a little complicated. So let's see. What do we need to do? All right, so here's artist's rendition of the paddle as well as the ball. So let's say here's our paddle. We know its length and its height. We took care to worry about that. It was 30 by 120. All right, so there's that. And it's always, the coordinates of the ball are always relative to its center. And, or sorry, not the paddle, excuse me. So this is the paddle. The paddle's coordinates are always relative to its center, and we are keeping track of where that paddle is in these variables. Paddle x and paddle y. That's always going to reflect where the paddle is right now. So I know where the paddle is. This particular coordinate is a combination of those two variables. It's paddle x and paddle y. Beautiful. All right, then I also have the ball. Let's say the ball just hit the paddle. It's right here. The ball has its own width and height. It's going to be 40 by 40 because it's a square, perfect square. There's 40 by 40, the ball. And the ball, we also know where the ball is. We have some variables that keep track of that too. That's down here. We've got ball x and ball y, just like that. So again, the coordinates of it are relative to its center. But we've got ball x and ball y to tell us what those are. Ball x, ball y, those are those coordinates. I guess I can put that all in one line. Beautiful. And so now the question is, what is true when the ball hits the right side there of the paddle? It's going to be a little bit complicated. So there's going to be something true about the x coordinates of both of them and the y coordinates of both of them. They got to line up in the exact right way. So like notice that the x coordinate of the ball and the paddle are very special. They only hit if they're right here touching, right? And that's going to be like, they need to be exactly this distance apart from each other, right? This half the distance of the paddle plus half the distance of the ball. Only if that's true. Only if that's true about their x coordinates. They're exactly that much away. Then it's potentially the case that we've hit the ball. Does that make sense? That's about the x only right now. So that's what, this is 15, this is 20. So only if that's true about the x's do we potentially have a chance at the ball hitting the paddle. So like, we're going to keep track of some stuff. So we know that the ball touches the paddle when some things are true. The ball touches the paddle when we have one fact now. We know that, all right, it might be touching the paddle if their x's are exactly this far apart. So how do you represent that as a condition in Python? Well, you got to use somebody as your frame of reference. Let's say it's ball versus paddle. It doesn't really matter. It's like, all right, when the ball's x is equal to, it's equal to what? Well, it's exactly this far away in the x direction from the paddle. So you need to use the paddle's x. So it's, all right, take the paddle's x, go 15 plus 20, go 35 units to the right. That's exactly what the ball's x should be. Paddle's x should be exactly that far away from ball's x. So it's got to be a condition involving both of them. Ball's x equals paddle x plus half the width of the paddle plus half the width of the ball plus 15 plus 20 or 35. All right. So there's that. And then for similar reasons as like as we were doing before for hitting walls, like it's possible that your speed was coming in so fast that in a frame like you weren't hitting the paddle and then you kind of went inside the paddle a little bit. So it's not just equal to, it should be less than or equal to. It's like it might be a little bit smaller than that due to the way that we're moving the ball every frame. So it's got to be that. But that's not the whole story, right? Because maybe the ball's up here. Sure, it's grazing the paddle, but it's not going to hit it. So there's also a condition involving the y coordinates. All right, so now the question is, where should be the upper limit for the ball touching the paddle? you have some options now as the programmer. You can be like, all right, I think that the ball touches the paddle. The last chance is right there. If the ball goes any further, then we'll say that the ball doesn't touch the paddle. Like, I don't think that's a good place for it. I think let's give it to the user. Tie goes to the user. Let's say that the last possible place that the ball hits the paddle is right there, right as it's touching the corner. Yeah, I think that would be a good way to do it in favor of the user, favor of the player. So like that's like the uppermost part where the ball is touching the paddle. Still, it just nicks it a little bit. That's fine. And then here can be the lower place where the ball is still going to hit the paddle. Right? Any outside of that, we're going to say that's not. It's going past it. All right. And so now this is another question. Like, all right, what's true about the coordinates of the ball and the paddle when the ball's up here and the ball's down here? And that's going to be, you see, that's going to be a condition involving the y coordinates this time. That's exactly the same game that we played again. And that's going to have to be true at the same time as the x coordinate stuff. Okay. So, all right. This is the upper limit for when the ball hits the paddle. This is the lower limit for when the ball hits the paddle. And so what is that? It's going to be, well, half the height of the ball plus half the height of the paddle. All right, a condition involving that. And so that's going to be what? 60 and 20 again. Again, like 60, that's down here. Take the middle y coordinate, go down 60, go down 20 more. Like that's the lowest part that the ball could be in and still be hitting the paddle. All right, so here's some more checks now. Let's do a check for this one. Like what's true about the y coordinates of the ball and the paddle when that's up there? So like, all right, the ball is just grazing. It just exactly hit the top part of the paddle when its y coordinate, the ball's y coordinate is exactly equal to the paddle's y coordinate, this much. Paddle's y coordinate plus 60 plus 20. That's the secret right there. So it's this height. That height from the center of the paddle. We need to check for that. All right, so that's, all right, it's equal to, well, the paddle's y plus 60 plus 20. Go up, like start here, go up half of that plus half of that. That's the upper limit for the y coordinate of that ball. All right, it's exactly there if it's touching. And we also want it to be okay, like even if it's down here. So like less than is fine too. Less than is fine. That means it's less than. It's still like within these ranges. So we want to do less than or equal to for this upper limit for the paddle. And then we have this range as well for down here. So like, all right, it's touching the paddle when it's exactly touching the bottom part right here when the ball's y coordinate is equal to the paddle's y. Let's see, let me get rid of that circle. It's equal to the paddle's y plus this much plus this much. So we're at the bottom limit of where the ball could be when we're exactly there. The ball's y is equal to the paddle's y, move down by 60, move down by 20. So minus 60, minus 20. And then we also want it to be considered to be hitting the paddle if it's anywhere above that too. So it's going to be a greater than or equal to, not exactly equal to. And there's my range. Do you see how that's going to keep track of? If we do these two together, it's like, all right, as long as it's from here down, that's this first one, and this one is like as long as it's from here up. We kind of want those to both be true at once, essentially. Actually, the name of the game is like when all three of these are true at once, and only if all three of them are true, that's when the ball touches the paddle. That's going to be the secret, because like if anything's out of whack, like the x is over here, but like it's within the y's, it's still not hitting it, right? It's only if they're all true at once. The ball's x is right here, grazing it some way, and then the y is either between here or here. Like it's somewhere along this line when both of those, all three of those conditions are true at once. So we need to keep track of all three. All right. Only if all three are true at once, that's when the ball has hit the paddle. Okay. So that's what we need to check for. All right. That's a very long-winded way of explaining that, but that took a while. All right. Does that make sense? Yeah, that's a little complicated for sure, but that's what we need to check right now. That's going to be the correct check. More or less, at least. Let's see. Paddle stuff. So it was this function we made, like bounce of hit paddle. So here it is. So now we know what to check. So all right, we need all three of these things to be true at once. We can put it into like a big long if statement if we wanted to, but that's a lot of code. So I'm just like I'll call this A. I'll call this thing B, and I'll call this condition C. And let's just like make some variables for those. All right, so we want A, B, and C to be true all at once. So like we'll call A, that's the result of, all right, checking if balls X is less than or equal to paddles X plus 15 plus 20. Like that's gonna, A will hold either true or false. That's just gonna make it easier for us. Like A is the result of doing this condition, true or false. And then same with B. B is, right, if the balls Y is less than or equal to paddles Y plus 60 plus 20. And then condition C will be the last one. Oops. Condition C will be the lower limit for the Y. It's got to be greater than or equal to the paddles Y minus 60 minus 20. And so those are my three conditions. I want them to all be true at once. So if A is equal to true, and B is equal to true, and C is equal to true, then we hit it. All right, we hit the paddle. If all three conditions are met. And just like I was saying for the game over part, this is a little bit redundant. So notice how if I'm checking if A is equal to true, that's really just like, because I want this condition to be true, to result in true, right? I just want it to be true if all of these things, A, B, and C, are equal to true. That's as easy as, like, these equal trues, they're actually redundant. Notice how if I get rid of those, it's still going to work, right? It's still going to be true if A, B, and C are true. So, like, it's true, it'll be true, and it was true, and it was true again, and that will still result in true. So, like, you don't need the equal true either. Like, if A and B and C are true, that's kind of how you can read that, then we did it. We hit the paddle. All three of those conditions were met. We need to do something. Okay? So now the question is, what do we do? All right? So just like when we hit the left wall, we kind of need to do all this other stuff again, like with the left wall. We need to rein it back in, right? If we try to go outside, rein it back in, and then also change the x offset because we're going to bounce off. So that's exactly what we need to do. Like you might have tried to go a little bit too far. Like let's pretend that this is the right side of the paddle. It's pretty much the same code that we had for the left wall, but we're not using the left wall code anymore, kind of, because that stops the game. Like we've moved it to the paddle. So this is what's going to happen then. It's like here's the ball. It's coming in this way with this direction, with that direction, let's say, which is a little bit down and a little bit left. It needs to bounce off with this direction, which is based on the original one. So it was still move a little bit down, but instead of moving a little bit left, like we're up here, move a little bit right. So it's going to be negate the x direction part, the x offset. So what is exactly what we had here? Like we're going to steal it from the left wall code. But also, like you might have tried to go a little bit far inside of the paddle. Like the ball might have like tried to go from here to a little bit here. We also want to rein it back in and make sure it's exactly grazing the paddle. All right, so we'll do that too. So let's hook all that up. So now, all right, where were we? Right here. We hit the paddle if all three conditions are met. We might have tried to go past the paddle, like a little bit to the left because we had like a fast speed, tried to move a little bit too much. If we tried to go past the paddle, move the ball to be just touching the paddle. That's what we'll do. All right. So that's going to involve the x coordinate. So it's balls x needs to be exactly, I want it to be like if it ever tried to go inside of the paddle, make it exactly equal to, the balls x should be exactly equal to the paddles x plus 15 plus 20. That would make it exactly graze it on the x direction. So balls x equals paddle x plus 15 plus 20. That'll make sure it's exactly grazing the paddle there. Balls x, set it to be exactly equal to the paddles x plus 15 plus 20. That'll put it right there, not inside the paddle anymore if they try to go inside. So just in case, just like make sure of that, that's fine. And then we want to bounce off that paddle finally. So bounce off by flipping the x offset for the ball. All right, and so that was exactly what we were doing up here for the left wall code. Technically, we can steal it from here because it's never going to actually be useful here, but I'll just keep it there for fun. Why not? But that's where that code needs to go. Right. Where's my cursor? Right there. So that's going to correctly change the direction to bounce off in the other x part, x way. So like it was coming into the left somehow. it's going to bounce off to the right for sure. But with the same y direction, could be moving down and to the right or up and to the right. Does not matter. But that should do it. And notice how I'm messing with some global variables. Ball x is a global variable. Ball x offset is a global variable. So just like I'm doing every other function, I need to mark them as global. So it's not trying to like make a local variable with the same name. That would mess some things up. So I think that should do it. I don't know what's happening there. But what else? What else? Yeah, I think that should do it. Yeah, we just bounce if hit paddle. We had some very complicated conditions to check. If they're all three true at once, that means the ball has hit the paddle. Rein it back in if it tried to go inside of the paddle a little too much. Make it just graze it if it ever tried to go inside. And then flip the direction so that it bounces off in the other way. I think that will do it. And we're always checking it every frame. Bounce if we hit a wall, and then also bounce off the paddle as well. So that should be happy. Let's try it. If I messed up, it will yell at me, or it will look weird. But yeah, it's not too many lines of code, but it's just a lot of thought. And wow, it worked. Cool. Let's try it again. Oh, that's so satisfying. There it goes, and it's bouncing off that paddle. Does that make sense why those conditions are doing it the right way? And then we can check like the upper limit, like it wasn't all hidden. It wasn't all inside the paddle, but still like the corner part, just the upper part of the paddle, still hit it. Bam. And it's still okay. Let's see if I can get it for the lower part of the paddle. So there it is. It hit the lower part of the paddle. It wasn't entirely inside of the paddle, but thanks to our conditions, it was still checking it right. So that should do it. Nice. And just for a weird quirk of the way the turtle drawing works, if you hold in the keyboard, it'll pause the turtle a little bit and slow him down the ball, which is kind of funny. But yeah. Pause at the same speed. What's that? Will it pause at the same speed? Yeah, kind of, because if you hold in the keyboard, it can only get so many key presses, and so it is going to slow it down to like a minimum speed, and it won't ever go slower than that, I guess. But it's still going to slow it down because it takes time to think about, oh, that key got pressed, I need to run that code. And so it's running it a lot, and it's swamped with that in a way, which is a little funny. But yeah, we still have that left wall checking code to end the game, and that's the last piece of the puzzle. If you ever give up or you lose, stops the game when you hit the left wall. And I think that's it. I think that's Pong in a nutshell. Let's see. I think that should do it. Are there any questions about why this paddle code is working? Or any ways that we hooked it in? Nice. Yeah, so that's pretty much it. That's Pong. You're going to have to rewatch the video if you want to have any questions about it, because I'm not going to give you this code, but it's working. Pong in Python. We finally have come full circle from Scratch. We made it in Scratch, now we made it in Python, and that's a great way to go out. So this is now going to turn into your final programming assignment of the semester. So let me go there and talk about that. Program assignment 9 will be due next week, December 5th. There it is, the Thursday. So here it is. It's available to you. And so yeah, here are your requirements. I want you to implement Pong by following my steps. All right. You can change your Pong as much as you want. If you want to go crazy, add 2 players, make the colors randomly change every time the ball gets hit, go crazy with it. I think that's a great way to get better with Python and learn new things. But as long as you have the features from today, that's the bare minimum, and you'll get credit. Okay? So yeah, feel free to look at the documentation pages if you want to do some fun stuff with randomness and changing the turtle around. But yeah, get this, work in yourself, and upload a video and talk me through the code. Try to make sure that you explain it a little bit so that I know that you didn't just blindly copy, and you understand it at least a little bit. But yeah, that I think is everything that I wanted to say about the programming assignment. It's just do what you did today, do what we did today yourself, and change it up as much as you want, as long as you keep the all the functionality that we had from this lecture. Okay. So yeah, I think that's all that I want to say for the programming assignment. and that is going to be the last one. So do next week with your final SAT. And I think that's the end of the slides, and that will be the end of the recording too.